So let's look at a problem where we want to take a truth table and implement it in Verilog. Now, of course, we could do a Karnaugh map and we could solve this and get the data flow expression, but I want to do something with a case statement because I more want to do an example where we have a table and we want to implement it in a case statement. So there's one thing that we haven't learned yet, and I'm going to hand wave. We'll get to it later, but I'm just going to kind of hand wave it and just take my word for it that this is how you do it. The thing is that we've only dealt with single variable values, or single bit variables so far, right? So just one bit per variable. And technically these are three 1-bit variables. But we know that we also have our row values here, right? 0, 1, 2, and we'll just bring that all the way down to 7. We know we've got our row variables here, and our row variables, that's kind of a 3-bit variable, right? This number here is the decimal value for these 3 bits, kind of concatenated into a binary number. So this means this is a 3-bit number. So I'm going to use something called a vector, which is just a multi-bit variable in Verilog. And that's not necessarily relevant right now, what we're really looking at. It's just allowing me to finish this problem here. So we're going to have a module, and we're going to give it a name. I'm just going to call it TT for truth table. And we're going to have an input. And let's just call our input in. And our output is X. Doesn't matter for this step right now. I'm just kind of saying out loud. And of course, we're always going to have our end module. And now let's declare our input here. So this is where we say the size, or how many bits our input is, in which case it's 3. It's a 3-bit variable. And so I'm going to say the bit starts at 2 and ends at 0. So we got 0, 1, and 2 are the bits here. Doesn't really matter. I'm just saying that this is a 3-bit value. And for the rest of this, we're just going to treat it as its decimal value. We're not even really going to pay attention to the bits. And this is in. So I said the size, right? It's 3 bits is all this is really saying. And then in is our input. Now let's declare our output. And output is just X, and it's just a single bit, so we don't do anything special with them. We don't have any wires or anything like that, but our case statement has to be inside of an always at statement, or a procedural block. And so what does that mean about our output? Well, that means our output has to have the reg keyword there. Now, let's make our always at statement, and I might be a little close with real estate here, but I'll put the space there. So we're going to have always, and then at, and then our sensitivity list. And so just whenever the input changes, so that means any of these 3 bits change, or in changes, we need to recalculate the output. So the only thing that goes in here is in. And I have to have a begin and an end. All right. Then inside here, we're going to have our case. And now for our case statement, we have a list, or not a list, but we need to say what variable we're looking at all of the cases of. In which case, we're looking at all the cases of A, B, and C, which is all encapsulated in. So we're going to put that there. And we also have this end case. Okay, so I think we've got all of our construct here. Now, what I want to do is I want to look for this case, I just want to look at all the ones, which is this guy, and this guy. So if it's row 2, so we'll just do this first one 2. And remember, so earlier I said how we can say numbers in different bases, but if we don't indicate the base, it's assumed to be decimal or base 10. So I can just put a 2 there. So if n equals 2, then we're just going to say x equals 1. And we can do that for the rest of our rows here. We've got 4. So if it's 4, then x equals 1. And the last one we've got is 7, and x equals 1. And then we want to throw this in here. This is our default case. So this is kind of, if it's not this, this, or this, then what do we do? Well, the default says x equals 0. So the way this case statement goes is if the input changes, if any of these bits in A, B, and C change, that means n's going to change. And then we're going to run this case statement and say, is it a 2? Is it a 4? Is it a 7? If it's one of them, then we'll set x to a 1. Otherwise, we'll set it equal to a 0. And we could list this whole thing out and not use the default statement, meaning that I could say 0, x equals 0, something like that I could totally do, and that would be fine as well. But it's sleeker, I guess, to just do it with just the ones, but sometimes that might not be what you want to do. Maybe you're not just doing a simple assignment. You might be doing something different for each one of these rows. Like, instead of this being just zeros and ones, it could be double a value, half a value. Maybe it could be add something to a value, subtract something. It could be anything in this kind of specification table would be at that point. We had to use a vector to make it so we could do something a little bit more complex, and that's what we'll get into later. What I really wanted to just demonstrate is how we do this case with multiple values.